So I suggest to wait just a few minutes, since more people dropping in, especially from the steering committee. So Sven, wenn du nachher, ich werde dir helfen, wenn du let's talk English. So if you run the machine, the discussion later, so I will help you in saying who wants to say something, or so if you can't see it, right?
I do have the chat open, so I can see the chat in parallel.
Yeah, so I will help you there. It's not so easy to follow all those people who want to drop in.
Peter, if you want to make a few of us co-hosts, we can help let people in.
Christine, great. So why don't you jump in and so help to look at the discussion state, so then I can lay back a bit. Yeah.
Okay.
So shall we start? I think we have now 30 people on board. Some others may join. So why don't we start here? So since I know Sven a bit, let me make some words, but not too many.
Tutta sta roba?
Oh, who was that?
Ti conviene dargli un'occhiata.
Could you all please turn on your microphone so that we don't have the other voices? So please turn down your microphone.
Logo è data invece che luogo è data, vabbè.
Peter, if you want to make me a co-chair, I can take care of it.
Yeah, why don't you do it? So.
Well, I don't have the access. You have to just click to the right of my name.
So I try to do my best, and also look at the guests who want to come in. So just say a few words to welcome Sven. So Sven is a member of the staff at the GWDG. You will explain what that stands for. It's not transformable or translatable to English. So it's one of the centers in Germany, one of the data centers and compute centers in Germany. I know the GWDG for many years, since I was member of the Max Planck Society, and the GWDG also serves the university in Göttingen, but also the Max Planck Society in its many different institutions. So and GWDG so I was chair of a committee in 2004 on 2005 actually for the Max Planck Society, talking about persistent identifiers. So it's a long time ago, and as a chair, I was able to convince the committee and the president to give a command to the GWDG to set up services, central services with the eye on persistency. And that's, I think, the starting point, Sven, when the GWDG started to decide to offer services of the kind of services which are important for FDOs, and you build up a whole set of services. And now I think it's time to turn over to you, Sven. So thanks for joining, and the floor is yours.
So, good morning, good afternoon, or good evening to all those listeners here. I'm just impressed how many people actually join, and I see a lot of familiar faces, and I hope I can tell something new, but I think some of the stuff some people actually know quite well, because they're, as you said, in the business for longer term than I do. But I try my best to give an overview of the current landscape, actually, what we do have. I missed the slide about GWDG. There's an abbreviation in German, it's called Gesellschaft für wissenschaftliche Datenverwaltung. It's basically saying something like data processing, data managing facility. And we serve, as you said, the University of Göttingen and the Max Planck Society with all different kind of services, starting from basic storage, tape and not tape, up to identity management, AI, network, and so on. So quite a few services We have about 200 employees at the moment, from which about 50 are focused on research projects, research development, and the other rest is, of course, maintaining, running services for the members of GWDG. To start with, yeah, so I saw already in the chat there's someone here in Prague. I'm also in Prague. I recently, so a few hours ago, the last session of the EOS symposium ended, and I can only tell that PIDs are everywhere in basically all sessions. It seems to be very important to have PIDs. And actually, the last event I had today was also getting the added value of PIDs in all contexts, from researcher up to funders. As you can see, it's really it's still a hot topic. It's getting even more a hot topic in these days. So I'm actually in the office, not in the office. I'm in the hotel room here in Prague, and I have to excuse Tibor Kalman, who would have also joined, but he's on the way back, catching the train home to Göttingen, and also Philip Wieder cannot join, unfortunately. A rough overview. The GWDG, I told you. So what is maybe the structure of EPIC? That's the part where we, so to say, are providing our PID services. So how is EPIC structured? What are the basic idea of EPIC, the policies about that? And more importantly, what is DONA? Because this is, so to say, the strength of, or the main role of GWDG within this EPIC consortium. Then we will have a short overview of the most important EPIC services. And at the end, we will look at the actual important and relevant projects and efforts we do in respect to PIDs and FDOs, actually. So EPIC is an international consortium. It was, the abbreviation slightly changed its meaning. It's now standing for Persistent Identifiers for E-Research, and it should, so to say, provide PIDs for the research community, and basically, so to say, improving the data management to provide an infrastructure for fair digital objects. And as you can see, there is the number of logos given here. We have several different partners, mostly in Europe, but also, of course, outside of Europe. And I see some people actually from these consortium here in the meeting room. As you can also see that these partners are basically from different well-known long-term existing IT centers, which do all have sustainable funding to actually maintain and run services, especially PID services. They do all have a very long experience in operation and management of these services, and they have the chance to actually provide proper service level agreements to users of the persistent identifier services. And so we are actually partners, not only in the EPIC consortium, but we do meet those partners also basically in all other projects on different European or national levels. So EPIC is, first of all, to say, providing PIDs. I will come back later a bit about the technical detail, but of course we do have added value. So what else can be on top of PIDs, and stuff like information types, templates, and more important, the data type registry, which will be a common and very basic building block of the new service landscape, especially in the European context. So EPIC is a consortium, and they come up with a memorandum of understanding. You can find all the information, of course, on the web pages of EPIC. Of course, the memorandum of understanding says there's a purpose of safeguarding the investments of scientific community and using handle system for research data. And here you can also see that the focus of PIDs is based on technical solution, technical implementation, the handle system. And we have a quality of service and policy document signed by all partners of EPIC, where the SLAs are described in more detail about the availability of the services, and other features, how to use and what you expect when using PID services. So very important is that based on these policies, we can actually provide the persistency in the PID. So PID is persistent identifier, and you can only make it persistent if you have a proper consortium having proper policies. So we have sustainability by technology. That means that the management resolving of PIDs, we know that there is quite a large number of identifier or persistent identifier systems available in the world, URN and other stuff. So what you need is basically that you have a stable system which is guaranteed to work for a long period of time, needs to be reliable, robust. And we know that there is quite a few around, as I said, and the most important or most well-known in the scientific community based on the publications is, of course, the DOI. In the library context, maybe more URN, but we have, of course, the handle system, and some people speak about handles when they speak about PIDs based on a handle. So that's just a matter of terminology, how you call it. We call it PIDs of EPIC when we provide the service via our EPIC consortium. The handle system, mentioned already several times, is the base of everything. It's originally developed by CNI. It's now in the version of version 9 available. And it's a worldwide system to create, update, and resolve PIDs. And it's basically has two parts, which one is the registration of the prefixes. And the second is software to actually mint or create, update it, and modify PIDs or content or metadata of PIDs. So we need, of course, first of all, having the prefixes, which we can also call a namespace. So we have namespaces in which groups of PIDs can be created, but I will come back to this later in a different slide. And CNI was initially developing this, I think in 2012, 14, I have to look up the number again. This was actually handed over to the organization called DONA, and now DONA is managing the handle software, and DONA is a non-profit organization where there's actually a dedicated slide to this system. So the handle system is the base, and we and GWDG are running this, of course, now since many years, as Peter Wittenberg mentioned. So we're quite experienced. We offer many services based on the handle system, and of course added values or APIs on top of that. DONA, as I said, is now responsible for the further development and distribution of the handle system. It was funded in 2014 in Geneva. It's basically a Swiss foundation. There is no dependency of DONA. There is no upper level organization which can, so to say, steer the decisions of DONA. There is a close collaboration with the ITU-T. And the important point here is that DONA has, of course, different members, especially there are 9 so-called multi-primary administrators, which are those organizations which are allowed to create and provide namespaces and prefixes. So DONA has a quite international board. Bob Kahn is actually part of this board, but also many other countries are involved in DONA. So it's a very international consortium. These 9 administrators or multi-primary administrators are organized as an example here in this simple graph. So you have on top the DONA, the Digital Object Numbering Authority, which has these currently 9 members. And as you can see in this block, that on the bottom right, The GWDG itself is directly member of DONA. So that means GWDG is actually one of the MPAs and is responsible for the namespace of the prefix 21. So what it means that GWDG is allowed to create namespaces in the range 21 dot, and then we can provide any consecutive number after this dot in different forms to provide PID services to different communities. As an example, because DOI is quite well known, for the DOI case, the International DOI Foundation is a member of DONA, and we all know that in IDF we have members like DataSite Crossref, which are then responsible to create or hand out namespaces for different journals and so on to create DOIs. In case of EPIC, GWDG is one of the funding members of EPIC and is therefore has a specific role because it's the organization which can, to say, hand out prefixes within the partners of EPIC. So partners of EPIC can request, based on our consortium agreement, prefixes so and can share those with their community. And this is a very specific and dedicated role, which is very important and very helpful to bring forward the idea and the flexibility of the handle system and the usage of PIDs. So not only that there are these MPAs in DONA, DONA is actually, so to say, responsible for the handle system, but has as a goal to build up the digital object architecture. So what is the digital object architecture? It's a logical extension of the internet architecture and should support the information management on a very generic level. So using PIDs to do this. And it should enable the interoperability across. In order to do so, we have, of course, the handle system, which is, of course, here called the Digital Object Identifier Resolution Protocol. It's actually an RFC, and we know it well under the name handle system. And on the other hand, we have another protocol, which is called the Digital Object Interface Protocol, which is more for handling the objects. And this is actually implemented in a software which is called Quadra. So you have different protocols with different purpose, the resolution of and the management of PIDs, and the other one is the handling of the objects. So based on these basic fundamental protocols and implementations, we do have different services developed in the EPIC context. One is from the very beginning, there was an idea to have an EPIC API version 2. This is back to the time when the handle system was not providing REST API. So the EPIC consortium decided to have an additional API to have a specific REST API. And also it allows to enforce policies. The handle system itself is quite flexible. This is good because we need this flexibility to actually implement new ideas such as FDOs. But on the other hand, we want to have policies for communities to restrict specific things, like what kind of information needs to be provided with the PID, or stuff like that a PID should not be deleted. So this was developed by EPIC and is still used and further developed and is part of the service portfolio. Of course, we do small stuff like providing simple services for customers, so they can just log in, create single PIDs. We can create profiles of PIDs on simple web UIs, just using PIDs in the backend. More important is the definition of PID data types, and now I have to be a bit more technical or try to explain something where we all use different words, different terminology. If you think of a PID, it's mostly a semantic-less string, but what you have in there is often a reference to an object. So this reference is expressed as an URL. But we would often like to have more information in this PID, such as an author, as a data site schema, or we can even think of other things which might be relevant for a digital object. Though we call these, in this example here, types. In the FDO forum context, it's nowadays maybe called more an attribute. Let's stick to the word type here for this presentation. We will see how we call it in the future. So types are basically metadata elements which are part of in PID. So why do we need a type registry? The problem is that a type can be quite complex or simple and can actually have dependencies. So if you think of a type like a name, which is just a string, or a person which has an address and a name and a family name, which is more complex. We would like to have these types somehow registered in a way that this is machine actionable and understandable for machines and humans. So what we need to have a place where we can describe a type and make it referenceable, this type, and add information about how to validate the value given for a specific type. So if you put a name to an author, is it correctly given? And this is very crucial, and this is often really hard to explain if you don't have proper examples, and I can speak 1.5 hours only about what is a type, but I try to make it short here and hope I can give you afterwards, of course, more details about this. But what we need to have basically a standardized way to describe and register specific types. A very simple example taken also from the well-known publication process is that you have an author, and here in the example, of course, my name is given for simplicity, so that would be in the PID, a key value pair, which is an author and a name Bingert, and below you see how it could like if you use a data type registry, a type registry, where you have then, instead of the semantic word author, you would have a reference to a description of what an author is. And you can see the value is more complex, could have contained the ORCID ID, the name, and some description of the person. And this all includes, so to say, the reference of this digitalized type, but also the validation and a human readable description. And this type registry is actually available as implementation, and it's called the Cortra software, which, so to say, supports the digital object interface protocol, the DOIP. And this is not from nowhere. This is basically a result of one of the working groups of RDA. And we call it, I often call it a way to standardize the metadata of PIDs. We know from experience that in PIDs, if you add more metadata, it can be quite messy and complex and maybe not standardized, and people come up with new names of attributes and types. So that's, we have to find a way to standardize this. In the FDO context, we would like to have a global data space. I try to maybe, this is one way to describe it. We want to have global machine actionable way to access digital objects or research data, and therefore we will need to have an FDO, a fair digital object. And this fair digital object do have attributes or metadata fields, and you can see on the left picture is roughly a description and what an FDO would have. An FDO consists of the bit sequence or the data you would like to reference. You have the PID pointing to this bit sequence, but you have various metadata. And this metadata, which describes the FDO, that could be also the operation you can do of the FDO, can be registered then in the data type registry. So you see on the right-hand side, there is solutions available to actually implement such a FDO using a data type registry based on the Cortra, or using handle system and using the handle system to register and maintain PIDs. The projects we are actually involved in and PID-related projects are the following. So we have, first of all, a very large project which is called the Fair Core for Wales project. It is has 22 partners, basically all relevant, important partners in Europe, which are well known for also working with PIDs and in the fair context, has a budget about 10 million euros, and it started recently and run until May 2025. And the goal is to develop 9 different fair core components. So we would like to have components added to the EOSC, which are the followings. I just mentioned briefly, and then I will go into detail in 2. So there's a research discovery graph, a PID graph. We have a compliance assessment toolkit in rate, service, and some service about software heritage. But more important, there's 2 services which should be implemented as a core component, which are called the data type registry and a meta resolver. And here you see the same thing again, so that we need to have on a European level a registry to be able to register these types. So it means that all the effort we do, and you see also in the picture depicted that GWDG is responsible in this large project to develop or implement this component. So we need to have this DTR, and we would actually go for the solution I mentioned before, using Quadra and the DORP for implementing the data type registry as a core component here. On the other hand, we're not only working on a European level. There's in Germany the so-called National Research Data Infrastructures, or the German abbreviation NFDI. It's actually something which is funded by the government and has the goal to bring together the community and to build up interoperable data infrastructures. The clusters which are actually built, or the community-specific clusters, are funded for 10 and more years. So there is really a long-term perspective for running these NFDI clusters and constructs. And these started just recently, basically in 2022. And GWDG itself is involved in these and several of those consortia. Important of these NFDIs, it has specific structure. So you have, of course, different clusters, different consortia based on different domains. But we also have, of course, a central organization which controls and steers the development in different consortia. And this is separated in different sections. This organization, which has at the moment common infrastructures, ethical and legal and social aspects, and so on. And you can see that there is based, of course, you have these domain-specific clusters. There is the wish, of course, to control and provide an overarching control of these things. Therefore, it was needed to actually fund a new cluster, which is relevant, which is responsible to develop and implement the base services. And this base service cluster is actually separated in different working groups again, which then write proposals for implementing the base services. And we do have in this base services a working group like long-term archiving, but also a base service which is responsible for PIDs on the national level. That means all development we do on both sides, on the national and the European level, do overlap, of course. So if we have to implement a type registry, it has to go on the same way as we would do on the European level. Or if we have requirements on the one hand, we do have the requirements, so you can use those requirements on the European level too. We are also involved in a European task force, the PID Policy Implementation Task Force. It's from the EOSC, and here is Tibor Kalman and Tim Samani from GRNet, the chairs. And you can see that in this PID task force, which is actually trying to build up documentation about policies and PID architecture, and they have also a look at the SRIA. You see that quite a lot of different partners and members are involved in this policy task force. We have 12 service providing organizations, 23 members in total, research committee is part of this. So there is a very strong overlap between all these different activities. And again, so this EO symposium again showed there is quite a lot ongoing activities and projects at the moment, and we have to find a common strategy how to implement or how to use PIDs in a reasonable way. An example where we are a bit ahead of just thinking in a strategic and a theoretical way is the way to use PIDs for instruments. It's again an outcome or recommendation of a RDA working group PID for instruments. They have at the moment a schema derived to describe the instrument. It's available on GitHub. And what we did is we actually implemented or we registered these schema as types in our data type registry to have this combined list of types is then called the kernel information profile. What we do is then we adapt this information or this list of types into a service, which is then called the P2Inst service, which allows then to register an instrument in a standardized way because it has to follow the list of types given in the data type registry. So this makes a fair instrument. Another thing we do is, besides of implementing, we of course have to see that we still follow our policies and ideas so that we have developed a service to mirror, to check the policy which is implemented by EPIC. We want to know, are we actually having enough mirrors to duplicate PID data? This is a project we've done, which is public available and was actually developed within the DICE project. So it's another European project where we can use our PID expertise. And here's a nice overview of the PIDs in the EOS landscape. And you can see that it's actually, it's in red marked, that you have PIDs in all different levels available. You have the PID policy documentation, we have the PID services which are based on PIDs, and we have the interoperability framework, which also includes the management of PIDs or to see if PIDs improves interoperability or what do we have to do to be interoperable. This also concerns a bit the data type registry because if you're going to have more than one data type registry, it needs to be interoperable, of course, too. GWDG itself is, of course, at the end also active in the FDO forum. We do contribute to the working groups BIG and TSIG. It's mostly Tibor Karlmann and Ulrich Schwartmann, who's also present here in the meeting. From our side, we want to be, and we are actually, I guess, something like in early adapters. And one of the goals of the FDO forum is, of course, to have a test bed. So implementing the idea or the specification which is under development into something real and into some real usable test bed. And if you look at the specification or the idea of FDO, you can actually pin it down to 3 main elements, which are then the types or the registration facility for types, the PIDs themselves, and a repository to maintain data which supports creation of PIDs based on or use and including type definitions. And this brings us mostly to the end of the presentation because GWDG is here in a very specific position because we do have all these services available here in GWDG. We do have, of course, as I mentioned, the handle system, which is our standard service, which we provide manifold for many different communities since many years. We are quite experienced in the meantime with data type registries. We do register types for different committees and different use cases. There's actually also an ongoing project with the German movie database organization. And of course, we do provide different kind of repositories or different implementation of repositories which can be used for such kind of test bed. So, and this brings me to the end of the presentation, that to say that we are really willing to actually come up with a test bed as soon as possible to see if we can make FDO functional. And therefore, I would like to end here and ask you if you have any questions about the previous slides. Thank you.
Thank you very much, Sven. Excellent overview about what you are all doing after 2005, when it all began. Let me add one thing to everyone, which may be of interest. So, which Sven did not mention, we're now opening, in fact, and GWDG is again part of the game, major part of the game, opening up to industry. So we're at this moment negotiating a big project together with big industry. And some of you may have heard about Industry 4.0 and Industrial Data Space, International Data Space Association. So we're currently talking with them to open up the services and integrate the services and integrate also industrial repositories in all what we are doing here, which Sven nicely explained. We are also opening up in this project the standardization process, which is very important for industry. So, I mean, the PID stuff is standardized, but all the registry stuff, which Sven mentioned, and so on, what we do in FDO is not standardized yet. So we are opening the standardization process with this money. And we're also inviting everyone to participate in a big test bed. More information will come. So that's another big source of information. And I would suggest, Sven, that you stop your presentation, since then we can see everyone. Yes, great. So I would now open the discussion, and I'm sure there are some questions to Sven. So please raise your hand or just start your microphone and come up with your questions. So I can't see everyone at the same moment here.
There's a question by Larry.
Yeah, go ahead. Larry, yes.
So thank you very much for the presentation. Enjoyed it quite a bit. This is more of a comment than a question. While I do agree that types are applied to metadata, I just wanted to make the point that the FDOs themselves could be typed. And it's not, when you say type metadata, of course, the kind of metadata, the kind of object an FDO is a metadata about it, but I had the impression that people might have thought, oh, that just means the smaller pieces, but the FDO itself can be typed as well. Do you agree?
I agree. There's actually a nice picture which was shown on the Leiden conference recently. I think it was Ulrich and Peter Wittenberg about the dependency of an FDO, which is an attribute, which is an FDO, which is an attribute, and so on. I didn't want to show this because it was too complex to explain it in a minute, but I agree what you said.
Okay, thanks.
There's a hands up by Romain.
Yes, it's a related remark because as we are working on FDO type, and the FDO type will be important to define the type of data, metadata that we will attribute to the data. And the ID will be also attribute to the data, and they have type. I was wondering what are the possible relations between ID type and FDO type. Perhaps there are no, or perhaps there are. What are your views then?
I'm not sure if I can really give a proper answer here. I'm not sure if I got your question correct. So I would ask someone else here in the round to answer this question. I think this is part of the specification definition now to answer those questions. And I think, so I'm not on the level to give you a proper answer here. Maybe someone
We have
wants to jump.
Sven, we have Ulrich also in the call. I don't know whether Ulrich wants to make a statement.
Yes, perhaps I can ask Roman what he is. He mentioned ID type. I'm not sure whether I've got what you are thinking about. This should be.
Roman, can you explain?
It's an open question because we at this step we don't have a clear and definitive definition of what is a FDO type, but perhaps ID for a kind of data on the type of data could be related to the FDO type too. So the definition of a data type for IDs could be related to the FDO type and FDO typology. I'm not sure to be better, clearer than before, but there should be
at least
relations.
At least I know on which level your question is actually living. So what we have in our discussion in TSIG and BIG about the implementation is essentially that that we are looking closer to what is used to describe an FDO, and we found out that this description not only is the type of the FDO, but it can be more. In other words, we will have metadata that describes essentially the type, and we will have metadata that goes beyond. We decided to provide, therefore, an FDO with a so-called FDO record, where all this information is collected. And the type description of this FDO will then be a part of it. And this will be essentially then described by a profile. So the whole FDO record again is described by a profile that says, well, these elements have to be in there, some of them mandatory, others perhaps optional. So this kind of description is in this profile. Again, then the profile, if it's described, will be an FDO again, and this way we finally end up in a chain of clear descriptions that are crawlable by a machine, and a machine can then find out what is actually given there and how it's given there.
Well, this is indeed a very detailed or difficult issue, which goes in deep detail. Let me say here, we are discussing this, and you are part of this discussion, I guess, in the working groups, and we're invite everyone who is interested in this detail and participate in this discussion to participate. So send an email to Ulrich or me or so, and we'll get you involved in this discussion, which is certainly not at the end. So thanks, Roman, for your question, and this will continue. But I would like now to give David Linke the word.
Yeah, thank you. So I have more question not on FDOs, but more on PIDs in general. Do you know of applications where people use it to label the concepts and terms in terminologies or ontologies? Because I found several issues with where they used other services to link to their concepts, and they all break after a while. So I was thinking if this could be also a good application for a handle system or something like that.
Sven, do you want to start? I guess that some others have answers as well.
Yeah, I can give you a very short first answer is that, yeah, we are thinking about different communities to do this. And so, and there was in the Leiden conference also some examples, but using different technologies reach a similar goal, I would say. Yeah, but please, someone else can add on this.
Yeah. Well, if I may add something, David. So I think when we talk about PIDs, it's all about accountability and responsibility, isn't it? So we speak about persistence, but there must be something behind to how you say, to give a chance of persistence. It's difficult for me to explain that in English, but I guess you all understand that. And what you often see is that in these projects, I was myself a developer, so not to blame anyone, right, of my colleagues. But what you often see is that people choose for some technology for good reasons, but they don't think of these two factors, accountability and responsibility, which has a long-term aspect. I don't know whether, so I stop here. I don't know whether other want to join in, Larry or whosoever, in this point with a short comment.
I can very short comment about the accountability, but there is this PID policy paper by Josk, which as you defines or tried to define some roles in this respect.
Yeah. So David, I think I personally agree with your final questions. Yes, PID, if there is responsibility, accountability behind that, then it would make sense. And we're discussing this now when we discuss about knowledge graphs, how to build a knowledge graphs, not just for the next 2 years or so, but it's knowledge which we build up. Well, how to make it such that this stuff is there in 10 years or 50 years or whatsoever. Yeah. It's a difficult question. Good. I see two hands. Jutta was first.
Hi. My question is about so if you can use some data for different purposes, you might need different metadata going with it. And I'm wondering how you handle that, because that seems to quickly lead to like an kind of an explosion of metadata. And also the question is, to which set of metadata do you actually attach the PID? I mean, do you have PIDs for each kinds of the different metadata sets that you might need for like different purposes? So it's kind of about the dynamics of the system.
Okay, I try to answer. So I would first distinguish between in FDO PID, so where we try to describe an FDO, and the second is an PID for what is we currently use for an research object. Let's call it like this. And that's one of the reasons why we have this data type registry, because we need to standardize and to limit to standardize and control somehow these metadata fields you mentioned. So often the community has specific requirements on a schema, and we sort of say implement or register this schema in our data registry, and then there's a governance model on top of that, which so to say controls that you don't have too many duplicated or unnecessary types registered there. So that's the chance of having a, so to say, more or less a central type registry to have the hand on the control over these metadata fields.
If I may add again something, Jutta. So in the FDO forum, so you don't have to have build FDOs, but if you want to build FDOs according to specs of FDO forum, then we make a distinction between mandatory attributes, which have to be there, optional attributes, which are the kind of standardized, commonly used standardized attributes, which Sven mentioned, but we also need to open up for attributes which come from communities. Since we cannot say to the climate people that they should do, they can't do this or that. So we need to have these three categories of attributes. Right? Sven?
So while I would understand FDOs that you have, the FDOs does have a given fixed set to make it an FDO. So whatever this set will be is part of the specification. And the community part is then on top of that. This is the difference.
That's right.
And of course, the community part is always limited, and you will always need to have a second source of metadata. I guess you will never be able to put everything you would have in a repository into a PID. But this is basically the discussion, the support we have to provide for the scientific part of the community.
May I join to go over to Maggie? Maggie has hand up.
Yes, thank you very much, Sven, for a nice overview. I learned a lot of details about your organization that I didn't know beforehand, so very useful. I just wanted to comment back on these questions about like sustainability and maybe also governance of these systems, because of course it is good to have a flexible system of many different federated services, etc., that are maybe also enabling communities to bring their own expertise into all of these things, especially with regard to which types that they need to register and work within in order to sort of fit both their legacy data and their new digital objects that they are creating all the time. But I think I see an issue with sort of chains of these things being one thing refers to somebody else's definition, and then that in turn may reference something else. And it only takes one breakage of such a chain to really make data or well, let's focus on data now, but of course it could be any digital object or any object with the digital representation that we are talking about here, to make that maybe potentially unusable, because it really depends on which part of this definition chain gets lost. If all the basic things are still there, it can probably be retrieved, maybe not by a machine process, but by a human who is intervening in the system and looking things up and whatever. But how do you think that a role like your organization can play in sort of hosting let's call it, I don't know, backups or replicating definition sets that other maybe smaller community related type registries, for instance, the information that they hold to ensure that it can be found later on?
Yeah, so first of all, of course, we are using also each registered attribute or each registered type. So now we should have started with the glossary actually, because now we're mixing types and attributes or metadata fields. So if we do a registration, we assign a persistent identifier. So this is by default persistent in the best way we do as an organization, as a consortium. So breaking the chain is already complex, but yeah, this is definitely a way to go to ask us to maintain and hold all the information and make it available for long term. I would a bit be reluctant in saying we should have many DTRs or type registries, as those also have to be interoperable. And the starting point is already the issue also, of course, of the FDO. What is an FDO? And we need to have to say in a description, a structure of an FDO, and this has to be the same in all type registries or FDO registries. And there's a high risk that this diverges, and so that's why we need to, at the first place, somehow make sure that it's a governance model. If there's a new type registry coming up for a specific community, that then you reuse existing work or work already done for doing this.
But types are not just related to, for instance, handles and the ways that handles and handle registries work, but you could also think of rather different PID system architectures. And also if you start thinking about not only having the digital object architecture model, but you also think of linked data and throwing in a mix of that. And I think many user communities today are increasingly working with a sort of mix of home rolled stuff and then standardized things. So I do think that this discussion has to be brought forward and be openly discussed, especially with early adopter communities that we are going to try to convince to go for this FDO concept. But I'll stay silent from now on. But as I said, it's important to pick up on.
Maybe that's something we should comment on, Maggie. So all our specifications should be approach neutral. Is that the good English word? So linked data should be part of or should be, should be covered by our specifications. and we have a discussion process. So if someone says, no, it's not the case, then we probably have to redo our different specifications. So Sven, sorry to come in here, but that's an FDO issue, I guess, right? So Maggie is right.
Yeah,
Maggie is right, and we need to make sure.
Yeah, definitely. And of course, I'm sorry that if I'm a bit biased here by mentioning handle system too often, maybe, but that's what I have done in the last days quite frequently. And there's, but I tried to show in one of the slides, there's many more identifier system and ways to describe metadata and so on. And of course, we should make sure that maybe all these things are also long-term available and persistent. Yeah, sure.
I saw that Ulrich has a hand up.
Yes,
and then
Ulrich.
Larry.
Yes, perhaps because Maggie mentioned these chains and the possible way or the obligation to maintain these chains in a proper rule and backups, making backups and things like that. Just one remark in this context: the amount of data that has to be backupped is quite small, not at the level of that what we call types at the end, which are then instantiations of these type definitions with a value. Those are somewhere in the world in these repositories, and they might become a huge amount of data. But the definitions itself is something which is it's currently in the range of megabytes still. It's not even gigabyte, so that can be handled quite good, and therefore there is a good chance that this can be backupped, and if there is an event, then it can be restored easily.
Larry, you had the hand up. Hands
up.
Ulrich
covered much of it. I just want to underline what Maggie said, and to say that I see this increasingly as almost a moral issue. We have the way science is proceeding now. We have to keep the space coherent and useful. Peter and I have talked about this many times. 50 years from now, and you can't tell me what the computing environment looks like in 50 years. So this is a lot of effort is going to have to go into that, and I hope good people will work on this in the years coming, and that there'll be funding for it. There just has to be. That's all.
Thanks, Larry. So we are now 7:30. So normally we are at the end of our sessions. But if there is an urgent question or another important issue, please go ahead.
There was a comment on the chat by Xeni. I'm not sure if I actually pronounce it properly. There's the other project which I didn't mention properly, so I'm sorry for that. So besides of fair core for EOS, there were I think 6-7 other EOS projects funded recently, which are on a similar level, but there's actually very close cooperation with the Fair Impact project. So GWDG itself is not part in Fair Impact, but basically many other partners in Fair Core for EOS is also in Fair Impact. And there was actually here in the EOS Symposium a workshop organized by Fair Impact.
So what does Fair Impact do, Sven, with few words?
Maybe Xeni can actually
is Xeni around? Here. Where is Xeni? Oh yeah, still around.
Yes. If not, I can try, but please go ahead.
There is a working package dedicated to PIDs. We're only starting to let's say specifying the road will follow further. But this issue that David Linke mentioned has been brought up. It's one of the things. I mean, the entities created inside the semantic artifacts, they require identifiers, all of them, and we're talking about like mass production of identifiers. These huge data sets, linked data. So yeah, there is the interest. The need has been recognized, but we don't really know exactly whether we will uptake this road down. And yes, we are very much interested in synchronizing with other projects. It's a very important part of our project, and we would be very interested to know whether other initiatives, relevant initiatives, are ongoing.
Thanks, Xeni. So we should keep in touch, Xeni, also from the FDO forum. So please let us have some chat or so in some moments in the next weeks or so.
There's a comment by, sorry, please go ahead.
Yeah. Maybe I can add to that. My name is René van Horik. I'm from Dans in the Netherlands. I was not in Prague, but some of my colleagues were. Well, actually, I am also in a fair impact in the task on persistent identifiers. There's a work package 3 on persistent identifiers. It has actually 4 tasks. And the first task has to do with setting up a coordination mechanism for EOSC PID service providers. And here you think about providers such as ORCID and ROR and obviously DataSite. There is a second task that has the name integration of PID practices into fair data management. And there you, I think this is led by CSC, I'm not sure. I'm personally most involved with task 3.3, and that has the very intriguing title, EOSC PID policy alignment and support. And but the EOSC PID policy, is there a PID policy or the PID policy? When I currently go to the workshop documentation, the working group documentation on the EOSC website, you see this architecture and of course also the policy document. And one of the things I would like to do in short term is get in contact also with, of course, with the working group and what is it? Forgot the people from GWDG are of course very prominent leading that, but there's also members of the EOSC working group that are also related to their impact. That's the third task, and the fourth one is PID implementation program, and for that, use cases are created. Things like how to cope with sensitive data and things like that. So that's the fourth.
Well, that's interesting. We should keep in touch, René, since this work which we just will start soon, we will collaborate with industry, and industry has specific interests, of course, in security. So, and that's something which we start discussing now with people from industry, but GWDG as well. You know, how to bring this in and all these security aspects into the PID framework. Let me say, there's more than the PIDs, but not going in detail now.
I have to say I'm still have to learn a lot. I still see the PID landscape, and one aspect is very simple and it's very clear what it is, but when you go into depth you see different services and things are newly developed, and well, to be continued. And by the way, CSC from Finland is leading the work package.
I see.
From
very good.
Helsinki. So
thank you very much, René and Xeni. So let's keep in touch. Are there any other questions, folks? That's not the case. Then I would like to thank Sven and his colleagues again for this excellent talk. Thanks a lot, Sven. And thanks all of you to participate in this meeting so late for the Europeans. So thanks a lot. And I will put the recording somewhere so that you can see it. Thanks a lot and bye-bye. Ciao.
Thank you. Bye-bye.